Hello my dear friends, welcome to my YouTube channel. Myself Dattu Patel, Assistant Professor from LJIT. Earlier lecture we are already discussed about the rank of matrices and inverse of matrices, system of linear equation for the homogeneous, system of linear equation for the non-homogeneous equations, etc. Today's session we are going to start with eigenvalues and eigenvector. Firstly, what is eigenvalue? Let capital A be a square matrices of the order n if there exists a non-zero column matrix capital X and lambda is a scalar such that Ax equal to lambda x, then the lambda indicated by the eigenvalues of the matrix A and non-zero column matrix capital X is called the eigenvector corresponding to the eigenvalue. The eigenvalues are also called the characteristic roots, latent roots, spectral values or a proper roots. Now Ax equal to lambda x, then Ax equal to lambda Ix, where I indicate by the identity matrices. Now for the simplification we can say that Ax equal to, for the simplification we can say that X minus lambda Ix equal to 0, then x which is common out, then we can write A minus lambda I into x equal to 0. The matrix A minus lambda I is called the eigenmatrix or the characteristic matrix, and determinant of A minus lambda I is called the eigenpolynomials or a characteristic polynomial. It is polynomials of the order n in lambda. The equations determinant of A minus lambda I equal to 0 is called the eigenequations or a characteristic equation of the given matrix capital A. The roots of the determinant A minus lambda I equal to 0 are called the eigenvalues of the matrices A. Let's see properties of the eigenvalue. First property, the sum of eigenvalues of a matrix is the sum of the principal diagonal elements, or it is also called the trace of A. Suppose we have the eigenvalues 1, 2 and 3, then sum of that eigenvalues that is same as trace of eigenvalues. Means suppose we have the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9 and whatever the elements in A11 position, A22 position and A33 position, then adding of that element that is same as the sum of the eigenvalues. Second property, the product of the eigenvalues of the matrix is the determinant of the matrices. Means whatever the matrices which is given and finding the determinant which is same as multiplication of the eigenvalues. Third property, the eigenvalues of the triangular matrices are the diagonal elements of the matrices. Triangular matrices means we have the upper triangular matrices or a lower triangular matrices. Then whatever the diagonal elements means A11 position, A22 position and A33 position, that is our eigenvalue for the triangular matrices. Fourth property is the eigenvalues of the two matrices A and A transpose are same. Means whatever the eigenvalues of A which is same as for the eigenvalues of A transpose. Let's see fifth one property, the eigenvalues of the A inverse are the reciprocal of the eigenvalues of A. For example, we have the eigenvalues of A that is 1, 2, 3, then finding the eigenvalues of A inverse that is 1 upon 1, 1 upon 2 and 1 upon 3 means 1, 1 half and 1 by 3. That means if lambda is the eigenvalues of matrix A, then 1 upon lambda is the eigenvalues of A inverse. If lambda is the eigenvalues of matrix A, then lambda raised to k is an eigenvalues of A raised to k, where k is any integer. That means we have to find the eigenvalues of A square. Then whatever the eigenvalues which is matrix A, then that is the squaring. Means suppose eigenvalues of A that is 1, 2, 3, then A square that is 1 square, 2 square and 3 square. Suppose we have the negative power, then must be remember eigenvalue should not be 0. Suppose we have two eigenvalues of a raised to -2, -3, -4, whatever, then we can find for the lambda raised to -2, lambda raised to -3, etc. But eigenvalue should not be 0. Suppose it is 0, then 1 upon 0, that is infinite, means we cannot get the eigenvalue. It is undefined. Let's see. If the lambda is the eigenvalues of the a, then the lambda plus or minus k is an eigenvalues of a plus or minus ki, where k is any integer. Its property is, if the lambda is an eigenvalues of the matrix A, then the k lambda is the eigenvalues of Ka, where k is any integer. That means, suppose we have the eigenvalues 1, 2, 3 and we find the eigenvalues of the 5a, that is, then multiply with the whatever the eigenvalues of a with 5. Here one note which is important, matrix A and A transpose has the eigenvalue which is same, but eigenvectors are different. For the matrix A and A transpose need not have the same eigenvectors. Remaining all the properties has eigenvectors are same for the matrix A and for the matrix A raised to k or A inverse or A plus k, A plus or minus ki or ka. Each and every properties has the same eigenvectors for the given matrices. Let's see characteristic equation of the matrices. Here firstly we have to discuss the characteristic matrices of the matrix for the order 2, that means 2 cross 2 matrices. That equation which is lambda square minus s1 lambda plus s2 equal to 0, where s1 equal to the sum of the principal diagonal elements of A, or which is also called the trace of the given matrices, and s2 equal to the determinant of A. Now finding the s1 and s2 and substituting in this characteristic equation, then we get the one characteristic equation and factorize it and we get the eigen values. Similarly, for the characteristic equation for the given matrices of the order 3, that is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0, where s1 equal to sum of principal diagonal elements of A, or which is also called the trace of A, s2 equal to the sum of the minors of principal diagonal elements of A, that means minors of A11 plus minors of A22 plus minors of A33, and s3 is the determinant of A. Now finding the values of s1, s2, s3 and substituting it in given characteristic equation and factorize it, then we get the eigenvalues of that particular matrices. Let's see one example. If A equal to 3 minus 1 1 minus 1 5 minus 1 1 minus 1 3, then find the eigenvalues for the following matrices. First one is A, secondly A transpose, thirdly A inverse, fourth one A square, fifth one 5A, and sixth is A plus 2i. We have to finding the eigenvalues and eigenvector. Then we have the must be square matrices, 2 cross 2, 3 cross 3, 4 cross 4, 5 cross 5 and so on. Means we have the order n. That type of matrices we can find the eigenvalues and eigenvector. Let's see. First, whatever the matrices which is given, that is A equal to 3 minus 1 1 minus 1 5 minus 1 1 minus 1 3, then characteristic equation is determinant of A minus lambda I equal to 0. Then in determinant 3 minus lambda minus 1 1 minus 1 5 minus lambda minus 1 1 minus 1 3 minus lambda equal to 0. Now finding this matrices to the determinant, and we can easily find the eigen values. Expanding this as a determinant and we can find the eigenvalues. Otherwise, with the help of characteristic equation, we can also find the eigenvalues. Let's see for the characteristic equation of the order 3, that is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0, where s1 equal to sum of principal diagonal elements of the matrix, that is trace of A, So here main principal diagonal position A11, A22, A33, that is 3, 5 and 3. Then adding that term, that will give you 11. Now S2, that is the sum of minors of principal diagonal elements. Then sum of principal diagonal, that is minors of A11 plus minors of A22 plus minors of A33. That is 5 minus 1 minus 1 3 plus 3 1 1 3 plus 3 minus 1 minus 1 5. Now expanding it, then 15 minus 1 plus 9 minus 1 plus 15 minus 1 and simplified 8, that will give you 36. Similarly S3, that is nothing but the determinant of A. Simplified the determinant, then 3 inside the bracket 15 minus 1 plus 1 minus 3 plus 1 plus 1 1 minus 5, that will give you again 36. Now substituting these values of S1, S2, S3 in characteristic equation, that will give you lambda cube minus 11 lambda square plus 36 lambda minus 36 equal to 0. Now factorize this term, that will give you lambda minus 2, lambda minus 3 and lambda minus 6 equal to 0. That is our eigenvalues, which is 2, 3 and 6. That is the eigenvalues of the given matrix capital A. With the help of properties, we have to find the eigenvalues of A transpose. That eigenvalues of A and A transpose are same, that is 2, 3, 6. Third one is eigenvalues of A inverse, that is lambda raised to minus 1, that is a reciprocal of the eigenvalues, that will give you 1 by 2, 1 by 3, 1 by 6. Fourth one is eigenvalues of A square equal to lambda square, that is 2 square, 3 square and 6 square, that will give you 4, 9 and 36. Fifth one is eigenvalues of 5A, that is 5 lambda, that means 10, 15 and 30. Sixth one is eigenvalues of A plus 2i, that means it is lambda plus 2. Substituting the lambda equal to 2, then 2 plus 2, that is 4. Substituting the lambda as a 3, then 3 plus 2, that is 5. Similarly 6 plus 2, that is 8. These all are the eigenvalues of the A transpose, A inverse, A square, 5A and A plus 2i. With the help of properties, we can find they directly. Let's see one more example. If A equal to 1 minus 1 1, 0 2 minus 1 0 0 3, find the eigenvalues of the following matrices. First one is A, second one is A transpose, then A inverse, A square, 5A and sixth one is A plus 2i. Let's see. Here our matrices, which is 1 minus 1 1, 0 2 minus 1 0 0 3, means our matrices which is in form of triangular form. Here in diagonal elements, which is 1 2 3 and bottom entries of the diagonal elements are 0, that means it is upper triangular matrices. Suppose elements of the diagonal elements and upper entries will be 0, then it is lower triangular matrices. Here given matrices which is upper triangular matrices, so the eigenvalues will be elements of principal diagonal. That means eigenvalues of the given matrices, that is 1 2 and 3 with the help of properties. Now eigenvalues of the A inverse, that is lambda raised to minus 1, that will give you 1, 1 half and 1 by 3. Eigenvalues of the A transpose, that is same as A, that will give you 1 2 3. Eigenvalues of the A square, that is lambda square, that will 1 4 and 9. Eigenvalues of the 5A, that is 5 lambda, that is 5 10 and 15. And eigenvalues of the A plus 2i equal to lambda plus 2, that will give you 3 4 and 5, means substituting the lambda as a 1, then it will 3, lambda is a 2, then 2 plus 2, that is 4, lambda is a 3, then 3 plus 2, that is 5. Here we find the, suppose A cube, then we get lambda cube. Suppose A raised to 5, then lambda raised to 5, A raised to 13, then lambda raised to 13. Similarly 7A, then 7 lambda, 8A, then 8 lambda, etc. Similarly you can find the any matrices has a eigenvector with the help of properties. This is all about the topics which is covered today for the eigenvalues and eigenvector. I hope you guys learn something from this video. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do this, share with them. If you want to watch more tutorial like this, then you can subscribe my YouTube channel, and whenever I upload the new video, you get the notification. If you have any query regarding this, then feel free contact me. Thank you so much for watching me.